This is going to be the follow-up lesson to the 3D model creation of the die punch that we covered the other day. And to get started, we're going to go into content. We're going to take a look at that die punch again before we get started. So, Introduction to Autodesk Inventor Solid Modeling. Click on this image. So here it is right here. We're going to be creating two-dimensional views for a presentable drawing file that can be given to someone who works in a machine shop or a tool and die shop who can take a piece of cylindrical stock, cut it to length, put it in the metal lathe, and actually cut that into the shape that you see here, which is this punch. So for that tool and die maker to be able to do that, they're going to need the drawing created with the necessary views and dimensions. Now, creating the 3D solid model, which I've already shown you for this, is a very important first step, but the second step, which is creating the drawing file, is just as important, if not more important, because that's what gives the physical dimensions that the person in the shop needs to actually build the part. So every 3D solid model that's created needs to have a drawing file to complement it. And those files have to be kept together on your computer because the drawing file is going to be taking the information from the part file to create those views. So if you're a little confused by this, don't worry because I'm going to be showing you how to do it. So to get started, I'm going to minimize this. I'm going to find Autodesk Inventor Pro 2019 and start it up. Now, I'm not going to be showing that image again. I'm going to have it open on my iPad next to me, and I'm going to be referring to it as I complete the drawing file for a little bit of assistance. Autodesk takes a little bit of time to load up this program. Once this white bar gets filled up, it's ready to go. Okay, so here we go. We're going to maximize this screen and we're going to go to open first. So we're going to be opening the 3D model that I created the other day first. So we're going to select it, hit open. Before you start any drawing file, make sure you have the 3D model open already. And there's a reason for this. So we're going to go to File. We're going to select New. We're going to hit New again. We're going to make sure that we're selecting English. And we're selecting ANSI inch IDW. Now this is your drawing file right here. So it has an extension of .idw, which stands for drawing. ANSI is a drawing standard. And in brackets it says IN. This stands for inch units. So we're going to select this and we're going to hit create. And this opens up your sheet of paper for your drawing plus your title block in the bottom right hand corner. Now this defaults to what is called a D-size sheet, and in my design lab I've got a giant printer, or we call it a plotter. It's actually suited to print a D-size sheet of paper, which is about 2 feet wide by about 3 feet long. Now, this is way too big for what we need. If I wheel my mouse towards me, I can zoom into the title block information, and it lists it right here, size D. Inventor can load up to a size E sheet normally, but that's way too big for our class. We will be working on D-size sheets later, but not today. So we need to modify this to be smaller. So over here in our project browser, where it says drawing resources, there's a folder. If I click this arrow to drop this down, there's sheet formats. We're going to select the arrow for sheet formats, and right here we already have a D size. Now it's always going to default to opening a D size sheet. You're going to have to change it manually every time. So you're going to have to go up here and select, in this case I'm telling you to select an A size landscape. So double click it at the graphic and then select OK. And that's going to change the sheet into an A size. Now an A size is the smallest sheet, and an A fits on a typical 8.5 by 11 piece of paper. So it can be printed off on a normal size printer we have in our classroom or something you would have at home. And you're going to notice that as soon as I switched it, it brought in one of the views already, and it takes that information from the die punch here, the .ipt file. So it reads the model, and that's why this needs to be open. So what I can do, when I flash my cursor over this square, this red broken square appears. Now when I see it appear and I left click and hold my left click, I can actually drag this around the screen, and I'm going to want to have this somewhere around here. I want this to be generally centered from the top line of the title block, from the top line of the sheet border. So this just has to be eyeballed as best as you can. So we have one view. Now we're creating a drawing for a cylindrical object. A cylindrical object typically only needs about 2 views. So we already have one. And that is 2-dimensional views. This is a 2-dimensional front view of the punch. So if I want to create a second view, I can come over here inside that square and I can right click and then scroll down to create view, come over to projected view and left click. And this is going to want to create the right side view, which I need. And this view is also visible on your iPad in that die punch scan that I have up in the module. You can see both these views in line with one another. So I can left click and then right click and then left click create. And that's going to finalize that view. So these two views are orthographically aligned, meaning that they line up with each other from every single feature. So if I was to, again, try to move the front view, it wants to pull the right side view up and down with it. I can move this side to side, up and down, no problem, because the front view is the most important view. It's the dominant view. So you can think of it like it's a parent and the right side view is the child, right? So you have a dominant view and you have a dependent view. The right side view is dependent. So if I try to grab the right side view, I can move it from left to right, but when I try to move it up and down, it doesn't want to move because it's a dependent view. So that's something very important you need to learn as you're trying to, manipulate your views around your drawing sheet. We also have another view that we're going to add, but it's not a 2D view. It's called an isometric view, and you would understand it as a 3-dimensional view. And this view is also visible on your iPad screen if you have it open next to your computer. You can, again, right-click on the front view, come down, find Create View, left-click Projected View, and I could create another right-side view, but I don't want to do that. If I could just move my mouse up, I get the isometric view, or the view in 3D. Isometric is the proper term. We'll learn more about that later. So I want to bring this to the top right-hand side of the sheet and kind of tuck it into the corner. And then left-click my mouse, again, right-click, and then left-click Create. And it's going to create that isometric view. Now, typically, designers, when working with a 3D solid modeling CAD program like this, when creating a drawing file, they will always create the isometric view in most circumstances in mechanical design work. And why not? Because it gives the person in the shop a very clear understanding of what it is that has to be manufactured beyond just looking at the 2D views, which are for dimensioning purposes. But this isometric view, it's large. I don't want it to be able to compete for my attention with these 2D views. So I'm going to change the scale of it. So this comes in at a scale of 1:1. So if I double click on it in this drawing view menu, it shows that it's a scale of 1:1. So we're going to want to reduce the scale. I would change this to 3/4, meaning 3/4 size. Once I've done that, I'll left click OK. It's going to change the scale automatically down to 3/4. Now what I need to do is just, again, I'm going to tuck this into the corner a little more so it's out of the way. And that looks better because now this is not overpowering. This is just kind of in the corner. We're leaving the 2D views as 1:1 scale. So if I double click on that, you can see the same thing. If I was to change this to a 2:1 scale, it would scale the view up twice the size. And it automatically brings the right side view with it, again, because of what I talked about being a dominant view. If I click on the right side view, it's grayed out because it won't let me change the scale. It doesn't have the authority to do so. So click cancel. If I click the front view again, if I change this back to a 1 and I change this to a 2, it's going to make it half size, which is way too small. So scale is something that you learn in math class, I think, and I think this kind of gives you a very good understanding of how that works. So drawing scale is very important to us in drafting and design. All right, so now we have all our views placed. What we're going to do now is we're going to add a center mark and center line annotation. So right now we're in the Place Views tab. So we're going to tab over one more to the right to annotate. And this is our dimensioning ribbon, where we're going to spend the rest of our time today. So it's drafting standard in mechanical design. Anything that is circular or a circle and anything symmetrical requires a center line. Now there is a flat spot milled on the right side of this, so this is more a radius, not a full diameter. So we're going to select this circle here, which is the largest circle that is a true circle, as our center mark selection. So right here, there's your center mark. We're going to left click it, and then we're going to click this circle right here. And that's going to automatically create a center line annotation for your front view. We're also going to create one for the right side view. Now, the center line should pass through anything cylindrical to ensure the operator that we're working with a round object, right? Because this doesn't look necessarily round from the right side view. It looks more like a block. So we're going to select center line, which is above, and we're going to select the center. This, when I come here with my mouse, this little green snap appears. When I see it, I'm going to left click and I'm going to come over and I'm going to find the one here and click again. And then right click, left click, create, and my center line is done. Now you're going to notice the center line will automatically give you an intermittent dash every so often, and it always extends a bit beyond the feature it's describing. Now this is not so it doesn't get confused with physical geometry that needs to be constructed or manufactured in a shop. And the center line appears lighter than the line work in the physical part that's being made. right? We don't want to confuse these lines with something to be made in the shop. It's just, again, a drawing standard that has to be added to a mechanical drawing. The reason I didn't select this line to finish it is because, again, this is not a true circle going all the way through. There's a flat spot milled here. So again, it's more of a radius, and there's no symmetry because that is also not appearing on the left side. So this is why I've stopped it at that line right there. So I'm going to right click and click cancel. I'm going to escape from my center line selection. So at this point, we're ready to start adding some dimensions. So there's one dimension tool that we're going to use. It's on the very left here. This is your general dimension. It's very easy. There's only one of them. So we'll select it. And then we're going to come in and we're going to follow the sheet. So I'm looking at the iPad screen. You should have this open when you're completing this on your own as well. We're going to select this radius. And we're going to drop a dimension about here. And hit OK. This dimension is visible on the image which you reference. They show it on the right side, but I'd like you to just copy what I'm doing for this drawing, and I'd like you to place it on the left side, and there'll be more of an explanation about that later. So we're not going to be copying every dimension exactly on the sheet. I'm basically overriding it. There's some things done incorrectly on that sheet on purpose. So I'd like you to follow my instruction from the video. But you should have it open next to you as you complete this. Next thing is the distance from the center line 0, 0 to the flat milled spot. So again, we're going to select the center. We're going to select this line. And we're going to pull a dimension up and hit OK. And what we can do, well, that should be fine like that. Okay, so we're going to hit OK. You're going to notice that when you do these dimensions and you're pulling it up, there's a little broken line that appears every so often. This is basically giving you a reference of where you should drop these dimensions. Otherwise, how do you know where to drop them off? Like, one person might put it way up here, which is too far away. So you have to get into the habit of dropping it at a correct distance. So I would basically have it around here. Similar to the distance I've chosen for this radius dimension. So we're basically just going to actually grab that 0.50 and place it on the right side here, as to not crowd this. So this numeric value does not crowd this R.63. So that's something else you can do. So those are all the dimensions needed for the front view. Now we're going to work on the right side view. And we're going to, again, start with a general dimension. And we're going to dimension from this line to this line. And again, see what happens. When I bring the dimension up, it basically gives you a little break with all these dots. That's giving you an indication that this is where you should snap it so it's not too far away. We're actually going to go one more up. And I'll explain why that is later. So hit OK. Alright, we got our 1.13 dimension. The image shows 3 decimal places, but we're going to fix that when we got all the dimensions on there. We're going to change them all at one time. So I'm going to show you how to do that instead of editing them one at a time. So we also have the dimension here, the width of the 0.63 diameter. So I'm going to select this line and this line, and I'm going to bring it in line. See that? When I bring this dimension up, and it basically wants to line up with that point 1.13. So that's where I'm going to drop it, and then hit OK. And we also have an overall dimension, which is the overall length of this. So we're going to click this vertical line and this vertical line here, and we're going to pull up that dimension. Now again, look at this. So when I bring this up, you see it break right there, those dots. That's where I'm going to left click and then hit OK. Now we still need to do a couple of more dimensions. We also have the 1 inch. Now, if I select this line and this line, it shows the 1 inch diameter dimension sitting on the part like this. Okay, now this is wrong. In an orthographic drawing like this, you should never leave dimensions sitting right on top of the object. So I'm actually going to hit the, I'm going to right click, say OK, select this dimension, hit delete. There's two options for this, and I'm going to allow you to pick the one you want. You could dimension it actually over on this side. So you could select this diameter, pull your 1 inch, and you're going to want to make sure you eyeball it so it's kind of in line. That diameter symbol, you see that circle with the line struck through it, is in line with that R. You know, eyeball that as best you can, and you can do this. I'm going to leave that there for a minute, or you could do this, but you can't do both. So don't leave both dimensions on here, because leaving both would be over dimensioning the part. We want as little dimensions as possible here. So if I select here and here, I can pull that 1 inch off the part like this. But I have to do something extra here. I need to show that it's a diameter. So if I move my cursor all the way to the beginning of these brackets, I can place a diameter symbol found up here and hit OK, and that's just as good. But I have to include that. So it's one or the other. I'm actually going to be inclined. I like this style better. It looks great too, and it's less work. So I'm going to left click, hit OK, select this, and delete that dimension. So I'm going to leave that one out. But I do need the 0.812 dimension. So I'm going to click this horizontal line, and again, Inventor gives me a clue where I can drop this, right where it becomes broken. I'm going to go one more, just not to crowd it. And again, I'm going to repeat what I just did. I'm going to move the cursor to the beginning, like that, click to the left, and I'm going to click the diameter symbol again, and then hit OK. And I have it. Now the reason I stretched out a bit more is because I'm going to be adding an extra decimal value that you see on your iPad image. So I need to leave a little bit more room. And we have one more dimension left, which is the radius. So again, I'm in general dimension still. I'm going to zoom in on this. I'm going to select the radius, and it allows me to create that radius. So again, I'm just going to drop it. It does, for radius dimensions, doesn't really go broken like the linear dimensions. So these ones you kind of have to eyeball to look as best as you can get them, but I would try to copy the kind of distance we've done so far. Not too close, not too far, somewhere around there, and then hit OK. So there you have it. So there we have all our dimensions. We are going to change the decimal value. We're going to add a third decimal. So what we can do is we're going to right click, left click OK. We can select any one of these dimensions. So I'll select that one. And up here at the top, we have a by standard, right? So this is our standard dimensioning toolbar. We'll talk more about this later, but we can right click this and then go down to edit dimension style right here. Make sure you're out of the dimension tool when you do this. Left click edit dimension style, and then where it says precision here, change this to 3.123. So this will add an extra decimal value. It should add it to all the dimensions, not just that one. Save and close. And it's done it. So as soon as it updated this one, it updated all of the other ones. You are going to notice that the iPad image has a 0 prefix in front of all the decimals. Now, don't worry about that. I don't see any value to show a 0 in front of the decimal, because I think it kind of goes without saying that that's the value before it. So I would just leave it like this. So you just have your decimal and your 3 decimal places in your dimensions. So notice that the first dimension is always a little further away from the part, and also the second dimension is not as far. So basically the first stack is a little further away to not crowd the part. So we give it a little bit of breathing room. This linear dimension here, it can be brought up about in line with that 1.125. So just kind of eyeball that one right there. So then it kind of goes broken, and I have it. Notice that the dimension extension lines also don't touch the part. They automatically leave a bit of a space. And again, that's so we don't confuse dimension extension lines with the actual part itself. We want to actually have a little bit of a break. So this is completely normal. So if you're wondering why they don't touch, they're not supposed to touch. This is something that it does for you when you're running the dimensions. So we have our dimensions done. We have one last thing to do. I'm just going to bring this down a bit. Center it a little more. Try to leave myself some space from that isometric view here. And that looks good. Okay, so the last thing we have to do is fill in the title block. So there's 2 ways to do it. I'm going to show you which I think is the easiest way. Would be to go up to File and select iProperties. And then click over to Summary and Title. Now this is all capitals when you type this. So make sure your caps lock is on. Type the title of the drawing, which is Die Punch. The author is who drew it. So I'm going to change my name to something more professional. I'm going to use my first initial in caps, a period, a space, and I'm going to type my last name. So this is how I want you to fill in the title block for your drawings. I want you to fill in your first initial, period, space, and last name. The company, in our case, it's the name of our high school. So type in Ancaster High School. And then we're going to tab over to Project. So part number. So this is going to be basically a drawing number. So meaning that every drawing has a particular numerical sequence assigned to an industry. So we're gonna kind of do the same thing here. We're going to use our course code as something we can use. So we're going to use the last 3 digits of our course code, which is 3M1. Which is, 3 means grade 11, M means mixed, and 1 means single credit. We're going to go a dash, and we're going to go 0, 1 because this is our very first drawing we've ever done. So we'll just have these numbers eventually climb in sequence. Revision number. This is something you can add. You can hit 0 because this is the original release of your drawing. So the original release would have no revisions to it. So it would be a 0 because it's an original creation. And we're going to click apply and OK, and we're going to see how we did. So we've got our scale, we've got our size, our drawing number, our title, Ancaster High School, Rev 0. And we also have who drew it, which is me. Now I'm going to be checking your work. So I'd like you to put my name under checked all the time this semester. Typically we have somebody from the class check your work, but currently I'm going to be checking all drawings at this time unless otherwise specified. So we can go up to File, again, iProperties, go to Project, and under, actually this is under Status here. Checked by. So you'll put my name here. And then check on the date to make it active. Check date and hit apply and close. And that is it. So that is everything you need to know to complete that first drawing file. It's a bit of a long video, but I think it covers a lot of important things that you need to know to be able to do this. So the next time we get together, I'm going to be showing you how to complete one of the other 3D models on that sheet. And until that time, good luck with this. Try this out and take care. Talk to you soon.